So we looked at the voltage when you're at standard conditions. So what happens now if we're not at standard conditions? Okay, what if our concentrations of our solutions are not 1 molar or the pressure of our gases are not 1 atmosphere? So what we're going to do is learn about the Nernst equation. So recall that from an earlier chapter, right? We had delta G is delta G standard plus RT ln of Q. Okay, and we just learned that delta G is minus NF E0, and if that's true, then the same thing is true at non-standard conditions. Okay, so we just remove the standard conditions, and now what we're going to do is we're going to set these two things equal to each other. Okay, so we're going to set this equation here equal to this equation here. So you have minus NFE equals minus NFE. Okay, sorry, we're plugging this in for that, and we're plugging this in for that. I don't know if I made that clear. Plus RT ln of Q. Okay, so does that make sense? This here went in for the delta G. This here went in for delta G0, and I still have that. So what I want to do now is simplify this equation, and you've got E is E0. Sorry, there's a 0 there. See if I can confuse you. It's kind of fun, you know. RT NF ln of Q. You'll just have to be able to use this equation anyway. You don't have to be able to derive it. So E is E0 minus 0.0257. Remember, that's what R times T over F equals if you're at 25 degrees Celsius, times the ln of Q. Okay, and hopefully you remember that Q is your reaction quotient. Remember, that's the same expression for K, just when you're not at equilibrium. Okay, and that is the voltage at sort of any conditions, right? Don't have to be standard, any conditions. And those are your voltages at standard conditions, when you have 1 molar and 1 atmosphere of everything. So let's try a problem. Let's say we have a voltaic cell in which this reaction occurs, O2 plus 4H plus, 4Br minus, 2 waters, and 2Br2. And the pressure of the O2 is 0.98 atmospheres. The pH of the H plus, so the solution, okay, is 1.24, and your concentration of Br minus is 0.15. Let's go ahead and change this right now to concentration of H plus, right? 10 to the negative 1.24, so that would be 0.0575 molar H plus. So what we want to know is, what's our voltage for our cell now that we're not at standard conditions? Okay, so the first thing we're going to have to do is find the standard voltage. And remember, we do that by first writing our half reactions. So 4Br minus goes to 2Br2. And hopefully you can see that there's 4 electrons involved there. Okay, so we're just taking this part and getting it to that part. And then I'll take the other half reaction, O2 plus 4H plus. Gives me 2 waters. Okay, and hopefully again you can see that I need 4 electrons over here to make it nice and even. Okay, and the voltage for this one is negative 1.077 volts, right, from your table. And your standard voltage for this one is 1.229 volts. So your voltage for this reaction is going to be 0.152 volts. Okay, so we know that. Now how do we find the non-standard voltage? Well, we're going to use the Nernst equation. That's the name of the equation. So E0 minus 0.0257 over N. So what's N? Well, it looks like N is 4. So so that's going to be a 4 when we do it. And the ln, now what's the expression for our Q? So products over reactants raised to their coefficient ignore solids and liquids. So there's actually no products, right? We're going to ignore those two liquids. So over the pressure of O2, concentration of H plus to the fourth, and concentration of Br minus to the fourth. Okay, so E equals E0. Okay, nope, this number right here. So 0.152 minus 0.0257 over 4 times the ln of 1 over 0.98, that was the atmospheres, 0.0574, there's your concentration of H plus to the fourth, times 0.15, that's your concentration of Br minus to the fourth. Okay, and this equals 0.152 minus 0.122, or 0.0297 volts. Okay, so the standard voltage was that, the voltage at our non-standard conditions in that. So when we have these particular conditions, our reaction has become less spontaneous. It's less positive. So let's try another one. When the voltaic cell is at 35 degrees Celsius, E is 0.035 volts. What's E0 at 35 degrees Celsius? So now we need to use the entire Nernst equation without that number, 0.025. Okay, so remember it's E is E0, okay, minus RT NF ln of Q. Alright, so we're going to plug all these things in. They said E is 0.039. We're looking for E0. Now why can't I just get that from the table of standard reductions? Because it's only true at 25 degrees Celsius, so we have a new temperature. So minus 8.31, got to leave it there because that's joules, okay, times 308 Kelvin, that's your temperature, over 4, that's your N, and this is Faraday's constant, 648 times 10 to the fourth. So all of that times the ln of, again, 1 over 0.98, 0.0574 to the fourth, 0.15 to the fourth. Okay? And you get 0.039 equals E0 minus 0.726. So E0 is 0.165 volts. And that's your voltage. So it becomes actually a little bit more spontaneous at that higher temperature. So that's how you use your Nernst equation.